Who knows what this is? This is a picture, but what is this a picture of? Yes?
This is the first computer bug.
Yeah, the very first computer bug, like quote unquote, literal bug. It was found in the Mach 2. I'm not sure if this is Grace Hopper's handwriting, but yeah, they found this moth in relay number 70, panel F. First actual case of bug being found. So some people will say that this is where the term bug came from. That's not true. I believe like even Thomas Edison wrote a letter to somebody once in which he used the term bug to describe a flaw in the system. So I'm not sure where the original term bug came from, but yeah, this is the first recorded instance of an actual bug causing a problem in a program. So aside from actual live bugs, or dead ones as they get burned by our computers, what kind of bugs do we find in our software? I'll give you just one, just to give you an idea of what I'm looking for. So there are security bugs. What other kind of bugs do we have in our software? Yeah.
Business logic.
Business logic. I've got that one in there. What else?
UX.
UX bugs. Yeah. User experience bugs. Regression bugs. Business logic. Accessibility, performance. User interface, internationalization, scaling. I should probably know when to stop doing that. So lots and lots of different kinds of bugs. This isn't all the types of bugs, but it's useful to know what kind of bugs there are for us to be able to address them differently because, yeah, because they are different. So what are some of the worst bugs you've ever heard of or caused? Anything that's like brought down production before, or can you think of a big company that had a really bad PR experience because of a bug?
How about when that one open source project somebody committed like remove-rf user directory or something like that?
What? I didn't.
Yeah, and if you like pulled it down, like it just destroyed your entire user directory.
Yeah, I don't know how you test for that, but but yeah, don't rmrf the user directory. That's a good one. Yeah.
I once deployed code that emailed a list of 50 people like 10,000 times.
What? Oh my gosh.
And I was on vacation, so.
So somebody else had to fix it, right?
No, I had to.
You had to fix it anyway. That's no fun. What other kind of bugs? Yeah.
Well, we didn't deploy this, thank God, but I accidentally had a function call itself, and I almost DDoSed our site.
Nice. Yeah, that would have been really fun, but not actually. That would have been awful.
Just took down test.
Yeah, that's good. Hey, it took down test. Hey, that's a good thing. Okay, Heartbleed. Anybody remember Heartbleed? So yeah, this was a bug in OpenSSL, and XKCD does a really good job of explaining what this is, what the problem was. So here's a client saying, "Hey, server, give me the word potato in 6 letters." Gives it back potato. And it says, "Hey, are you still there? Give me 4 with, or bird with 4 letters." And it gives it back bird. Okay, hat, 500 letters. Oh, that's very interesting. Let me take down all of that information. So this was actually a fairly straightforward problem in a very widely used technology. And there's actually heartbleed.com now to describe the bug. Yeah, that was a pretty critical issue. Cloudbleed was actually pretty recent, and this is the root cause of the Cloudbleed bug. Basically, Cloudflare had a DNS issue where it would leak customers' data to like a bunch of other sites that were using Cloudflare, and the root cause was in this generated C code that did what's called a buffer overflow. And so somehow P got incremented over PE, and so this double equals check never failed. And so they would continue to send more data that they probably shouldn't have. Yeah, probably want to test your generated code and use snapshot testing to do that, which we'll talk about later. It's pretty cool. So here's another one. In 1962, an $80 million rocket exploded. Yeah.
Yeah, David in chat says Therac 25 was a bug in a radiation therapy machine, so it actually killed people.
Wow. Yeah, I'm really glad that I don't work on software that like
Software that,
that could
kills
kill
medical
somebody.
equipment.
Like I just work on software that could like lose PayPal tons of money and prevent people from sending money to their family and loved ones. So, but yeah, it doesn't kill people. Hopefully, yeah. Bugs are a big deal. So this rocket exploded for because of a typo. It was like a missing hyphen. And what was interesting about this one is the code path was actually in an edge case, in an error case, handling an error situation. The rocket somehow gets disconnected, and this code was supposed to say, okay, don't do anything until you get or the right information from me. And instead, it decided to just kind of like go crazy, and it was falling to the earth. And so the engineers said, we should probably make it explode instead of land in someone's backyard. So typo in an edge case. So test your edge cases. And that was like 1962, $80 million in 1962. That's a lot of today's dollars. And then it's a lot of then's dollars too. In 1999, NASA lost $125 million Mars orbiter. And this one is actually also quite interesting because the problem was that there were two teams working on integrating software together. I don't know why that's not loading, but the one team was using the metric system and the other team was using the weird finangled system we use. What's that called?
Imperial.
The what? Imperial system, yeah, thank you. And so they didn't convert their units, and now we have a Mars orbiter floating off in space, probably like destroyed by now. That was $120 million. Yeah, so test your edge cases, test your code. These bugs are like, and the thing is, these bugs aren't necessarily a failure of like engineers. We all make bugs. Like it's inevitable. What the failure is in the process of identifying problems in the system and making sure those don't actually ship. And so what are some things you can do to prevent bugs? I'll probably just answer this one for you because I'm looking for kind of something specific. And I'm saying this in a very specific order. The first thing you should try to do to prevent bugs from ever happening is use types. Flow and TypeScript bring types to the language, and once you add types, there are a whole slew of tests that you don't even need to write. I don't need to worry about what happens if I call this function with a number when it's supposed to be a string, because Flow won't let me do that. So yeah, static types, if you can prevent a bug using static types, do that. If you can't, then lint. Use a linter that will say, hey, if you call this logger function with the request object, it's going to take a full minute to log that out and format it and everything, and that'll like spike our CPU. This literally just happened to my team. We now have a linting rule that says, hey, don't pass the request object to this logger because it is way too big. You're supposed to pass like the body or something. And then if those two things won't do it for you, then you start thinking about testing. And there are many different ways to test. So what kind of testing can we do?
Unit testing?
Unit testing. Very good.
Integration testing.
Integration testing.
Regression testing.
Regression testing. End-to-end testing, E2E. Penetration testing, performance regression, accessibility, internationalization, tons and tons of different types of testing. And we don't have time to cover all of these things, but they're all very important. And not doing them comes with a whole bunch of trade-offs. Doing them comes with trade-offs. But the more of these forms of testing that you implement, the more confident you can feel that you could ship what you've created.